just wait a couple more minutes. All right, I think we're good to get started. And if anyone else joins us, hopefully we won't be that far along. So I'm just going to share my screen. Thumbs up if you can see everything okay. Awesome. So throughout this workshop, feel free to interrupt me at any time. You could sort of unmute your mic, and you can also put stuff in the chat. I'll try my best to sort of answer all your questions. If I'm going too fast or too slow, please let me know. I'll slow down. If you want me to go over something that we've done again in more detail, I'm more than happy to as well. Sounds good? Great, let's get going. So welcome everyone to Introduction to D3.js for Data Visualization. And first up, these are some links. So I'm going to put the links to the slides right now in the chat so you can follow along. There we go. Thumbs up if you got the link. Great. And this is what we're going to be creating today. So that's the first link. And if you go to the link, you can wait for it a bit to load, or you can hit refresh. And so what we're going to be creating is looking into D3, this library that I'll go into more about. And we're going to be creating a bar chart, although many other types of charts and graphs are possible. And we're also going to be creating a map of the states. And we're going to be coloring it in, trying out different effects, things like that. Cool. As you can see, it's a bit topical, but we're not going to be swayed by actual outcomes or data. We're just going to do a little play sort of at the election for our own benefit and just for fun, basically. All right. So first, let's just get right into it. What is D3? If you go to the D3 website, you'll see it says data-driven documents, but that really doesn't make much sense. So what D3 is in my experience, is just a toolkit or an abstraction over your regular HTML, JavaScript web page. It's just a sort of system or like pieces of code, a library of code that people have built for you to work with stuff in your HTML web page more efficiently. And that's really all there is to it. There's nothing magical about D3. It's just a lot of code that someone's already written that we're going to be using to create our charts and graphs. So to sort of explore this even further, let's sort of revisit this idea of what an HTML web page or a document is. So if you've ever sort of seen a website and seen the source code for any website, you'll see that it consists of a lot of different tags. This is what forms the HTML document. So we can take a look at a website right now. Let's maybe take a look at yale.edu. And if you just right-click it, and whatever web browser you're in Chrome, Safari, it might be slightly different, but it's basically the same. Just right-click and inspect, or do right-click and view page source. So if you view page source, you can see that there's a lot of like HTML tags here. And these tags include like buttons, forms, nav bars, divs, headers, things like that. And all of these make up the structure of a web page. So any web page is built up of lots of different elements. And all of these elements, if I can just go back, are also kind of nested. So you see this form, for instance, to create the search bar here. So this search is, it's not just like one sort of element, but there are elements inside of other elements. So inside your form, you might have a div, which is just like a unit. And inside of a div, you might have a button, some text, things like that. So we say that HTML documents form a tree of nodes of different elements. And this forms something that we call the document object model. So it's a fancy name just for saying that your HTML document consists of a bunch of elements that are nested one within the other. So your HTML tag might have a head tag, which might have a title. Your body might have an H1, A, href, and things like that. So any questions so far about what HTML documents are? Great. So to bring it back to D3, what D3 does is just helps you manipulate HTML documents in an efficient way. So it'll create like a bunch of head tags for you, body tags for you. It'll create path elements for you, circles, rectangles, things like that. And D3 is just a quick way of managing an HTML document. So let me explain, let me go further into why we need D3. So it's actually possible to create HTML graphics without D3 at all. So HTML actually has two mechanisms to do this. One is called SVG, and the other one is called Canvas. And we're going to explore both right now. So to start writing code, we're going to use this sandbox online called Code Sandbox. And the benefit of doing that is we don't have to set up any development environment locally on our computers. So it's like a nice way to do that. So let's go to codesandbox.io. And let's just create a new sandbox. So if you don't have an account, don't worry. You can create a sandbox without having an account. It'll just be annoying and keep asking you to sign in, especially when you click save. So if you want to get rid of that notice, feel free to make an account, but you definitely don't have to. So I'm just going to give it a minute, or maybe a minute and a half. Thumbs up if we're ready to continue. Right. Feel free to stop me if you need any time or want me to explain anything. So we're just going to create a new sandbox now. And so now you have a bunch of different options. And these are all like, it's interesting to just look at this. There are a lot of different frameworks out there. So D3 is not the only framework for managing HTML documents. One popular one that you see out there a lot is called React. And that's also a way to manipulate an HTML document. And you could totally make your charts, graphs, maps with React as well. But it just turns out that D3, for the things that we're going to make, like this particular map of the states, these bar charts, is just purpose built more so for data visualization than other libraries like React are. And so you have a bunch of these like Vue, Angular, Preact, React. All of these are just mechanisms to work with your basic HTML and JavaScript in a nicer way, but you definitely don't have to use them. And in fact, what we're going to demonstrate now is you don't even need to use D3 to create some of these graphics. So we're just going to click vanilla, which just means like plain old JavaScript HTML. And let me know if you can read this text all right. Otherwise, I can make it a bit larger. Is that a good size? Cool. So we're going to make a few changes. First off, let's just delete everything here. You can keep your style CSS. A CSS file is just like some styling, basically just setting the font family to be a sans font, but you could remove that line too if you wanted. That's no problem. So we're going to make our index.js completely empty. Here's our HTML page, or document rather. And this is where you can see they've scaffolded out some of the tags for you. And we're also going to make a few changes to this. So we're going to remove this line, line 10. We're going to take 12 and 13, and we're just going to put them in our head for now, like so. We're going to leave our body completely empty. Stuff is going to go there later. On line 7, where it says script source, well, I just brought the script up here into the head. We want to add a few other properties here. So the first one I'm going to add is defer. And the next one I'm going to add is module, type equals module. If you click save, you'll see it formats everything for you nicely as well. So the reason we do this is a bit out of scope, but it's just that our sort of JavaScript that we're going to write loads quickly, like doesn't throw up any errors, things just work. And the reason we're setting it up like this with type module is we're going to install D3 in just a moment, and doing it this way makes it a bit easier. So we can totally ignore what we just did right now, but it's necessary to do. Thumbs up if you're good so far.
And
Cool.
I said this in the chat, sorry to interrupt, sorry, but if anyone is feeling like they're behind or if they missed something, please feel free to shout it out. But also I'm hovering around the chat, and I'm also happy to jump into like a breakout room and talk separately if you're having any trouble or confused on something. All right, back to you, Sam.
Awesome, thanks, Antonio. So can you make the, yeah, definitely. Does that work well? Great. So let's try experimenting with some HTML. We don't really need to know much, but H1 is a common one that you can use for headings, like maybe poll results or something like that. And on the right, you'll see your preview of the web page. You can write in paragraphs too. And so there are lots of different tags you can use in HTML. You can add in images as well in the same way, but you need to have like a source URL. So maybe like google.com/cat.jpg. That's how you can add images. So that's just your basic HTML structure. Everyone good so far? Cool. Has anyone not been able to get to this point? So we can just take a quick look. All right. If you haven't, feel free to shoot us a message and we can do that. So now just to bring it back to the presentation, sort of what I claimed was that we can make all these graphics without using D3 or any special library, and that D3 is just an abstraction over these basic concepts. And so the first thing I wanted to explore was SVG, and SVG is also another sort of type of tag. It's called scalable vector graphics, and inside of an SVG, you can put in circles, rectangles, text, basically anything you like. So let's take a look. Let's create an SVG tag here. And immediately what we can do, just for us to better visualize what's happening, is we can give it a border. So a 1 pixel border, which is solid and black. So it's just an empty SVG, but now at least we can see it on the page because it's not just like a white page. The other thing we can do is give it a width and a height. So out here, maybe we can say the width is 200 and we can say that the height is 200. Like it had a width and height before, but now we're being explicit.
Can you copy the code into the chat?
Yep.
Tom?
Yeah.
Thank you.
Also, for those of you who joined a bit later, I'm not sure if you can see the previous stuff in the chat, but there are also links to a link to the slides that I just posted. Okay. I realized that some of the text in my screen is cut off, so I'm just going to, and you can do this too. If you just press Command-Shift-P or Control-Shift-P, it opens up some settings, and you can just do toggle word wrap. And it'll just wrap your text for you, which is quite nice. Great. So now let's sort of demonstrate what kind of graphics that we can make just by hand. So we can make a circle, and right now we won't see anything, but that's because we should give it a fill first. So a fill color can be any sort of red, blue, a hex code, an RGB value, but I'm just going to say red for now. We still won't see anything because that circle is extremely small. So we need to give it a radius, which is just with the R property, 5. Now you see that it's at the top left corner, because for SVGs, and this is relevant to our discussion with D3 as well, they start at 0, 0 being the top left. So not the bottom left as you might be used to, but the top left. So knowing this, we can set the X and Y position of the circle within the SVG. So we can just say that the X is maybe at 10 and the Y is maybe at like 20 or something like that. So just a second. Just trying to close out of some stuff. So the way you specify this is with CX 10 and CY 20. And that's just what the position of it is. Is everyone following along so far?
Can I ask a question?
Yeah, go for it.
Yes. So the X is increasing as you go from left to right, and the Y is increasing as you go from top to bottom?
Exactly. Yeah. So for instance, let's set Y to be 50 and it'll go down lower. Maybe 100, it'll go down to the middle. So remember that our SVG is width 200 and height 200. We were explicit about this. And so our coordinate system is set up going from 0 to 200 from left to right and 0 to 200 from top to bottom. So if we translated it down all the way, it'll sort of be cut off, but that's because it's the circle's sort of point is in the middle. We use the center of the circle as the sort of anchor point by which it translates around. With things like rectangles, it's a bit different. And that's with the top left corner. And so we can take a look at how to do rectangles as well. So I don't really have prior knowledge of how all these tags work. So I just do a quick Google to see what's possible. So rect in SVG, and we'll just look up the documentation. So to create a simple rectangle, all you need to do is supply a width and a height. And you can also supply like an X position, a Y position. So we'll just copy this code over for now. And so we have a rectangle here, width and height 100. And then we can also give it an X and a Y position. But notice here that here for a rectangle, it's from the top left corner. It's sort of anchor point. Any questions so far? So oh yeah.
Sorry about that.
Sorry, go for it, Antonio. What was that?
Sorry, I asked to paste it in the chat. I think something that people I think often get confused by or might accidentally mess up is that these shapes that you put in should go within the SVG document, not beneath the tag.
Yeah. Yeah, exactly. Yeah, so it's nested. If we go back to this idea of the document object model, the things that contain other things. So these circles and rectangles, they only work within your scalable vector graphics tag. Outside of it, it doesn't really make a difference. So this is like your container for your vector graphics. And inside of that, you put in all your shapes. That's a good catch. So the argument I was making earlier was that you could totally make sort of the final result that we had here. You could totally make your bar chart just using SVG by hand. So you'd have to figure out where everything goes, but you can imagine totally just making stuff for Peter Salovey, Handsome Dan, etc., just specifying the rectangle's width and height, and also its X and Y position. But what we want is to do this in a nice, clean, reactive way, where D3 controls the data and just puts stuff onto the screen. And we'll see how to do that in just a moment. So the other sort of solution for controlling graphics, for doing HTML graphics without any sort of framework is just to use Canvas. And this is something else you can do. And the way Canvas works is, if I just go back here, you have an SVG tag, but you can also make a Canvas tag. And you can give it an ID, whatever you like my canvas. And this is how we're going to reference it in our code. We can also give it a width and a height. And we can also give it a style. There we go. So now we have an identical sort of container here too. But the way to actually put shapes and stuff inside of a canvas is not through HTML. So you don't specify them declaratively, like with circles and rectangles, but rather you go through your JavaScript code in order to manipulate the canvas. So thumbs up when you have the canvas tag, and then I'll sort of switch into that other file, the JavaScript file. And I can also copy it here for you in the chat. All right, so now how can we use JavaScript to interoperate with your HTML? So one of the most common things you learn is how to reference HTML nodes within your JavaScript. So document refers to the whole HTML document, index.html. And we get element by ID. What's the ID in this case? My canvas. And we can assign that to a variable. So let canvas element be this variable. So now that we have that canvas element, we can do things to it. So we can insert stuff, we can hide it, basically anything you like. So in this case, well, the way to use the canvas, and I don't know this, the only reason I know this is because I've Googled up the documentation. So there are lots of functions out there to manipulate a canvas, but the way to sort of interact with the canvas is that you just access the canvas's context, and then you start doing stuff to it. So see if you can follow along. We just take your canvas element and you get its context. And I'll try and give my best explanation for what each line is doing. In this case, we want a two-dimensional context because we're drawing in 2D, although it's possible to draw in other dimensions as well, like in 3 dimensions as well. And using this context, we're going to begin a path. And then we describe what is that path that we want to begin. So we want to draw an arc. And as you're sort of working, you see helpful tips from your editor as well. So it expects an X and a Y, a radius, a start angle, and an end angle. Okay, so X and Y describes the position of the circle in your whites, in your sort of outline square. So say we want it straight in the middle, 100, 100. And then we need to give our arc a radius. So say we're going to give it a radius of 10, a start angle. So how does the arc, it sort of draws it in a loop like this. So we start at 0 and we want to end at 360 degrees, but it accepts this in radians. So we just say 2 times math.pi, which is the equivalent of 360 degrees in radians. So we do that, and we won't see anything yet because we haven't given our arc or circle a stroke. So we need to do that now. And there we go. You can specify what you want that stroke to be, like red or something like that. You can also leave it blank and just color it for you with black or something. So this is how you can draw circles, squares, and shapes in Canvas. So this is very programmatic. You use JavaScript to manipulate like that piece of the canvas. So what questions do you have so far about Canvas? Or even SVG or anything so far? Was everyone able to follow along? Awesome. Cool. All right. So
can you show us the HTML again, please?
Yeah. I can also paste it into the, I think the HTML hasn't changed since I last pasted it into the chat, but I can also paste the JavaScript into the chat. There we go. Cool.
So just a quick question.
Oh, yeah.
Yeah. So you set the starting point. So the circle in the canvas is exactly in the middle because you gave us the 100, 100. That's
Yep. Yep.
Mm-hmm.
And the coordinate system works in the same fashion. So top left is origin.
But the reason for that is because you defined the canvas to be 200, 200, right?
Yeah, so the canvas's width and height is defined here. You can also do this in JavaScript. So when you have the canvas element, you can sort of modify its attributes straight within JavaScript too. So you can just say, I think it's attributes or something like that, and you can modify it here. So attributes width equals 200, attributes height equals 200.
Simon, I have a question. If you can do, so you did width is 200, height is 200. Can you, like in CSS, do this as instead of 20 and 20, can you do 50%, 50%?
I think so. I think you should be able to. And that's usually done using a CSS transform. So let me see if I can do it here. So I'm going to do it with SVG now because I'm not sure how Canvas works. But with the SVG, say you have this circle that we have at 10 and 200 at the moment. When it's 0, 0, it's right at the top bottom left corner. What you can do is you can put it in a group, and this is another tag in SVG, and you can put the stuff like circle or something inside. And then you should be able to give it a transform, which is say something like a translate, maybe 50, 50. So it'll move in some sense. Let's see.
But can you just in the CX write 50% instead of 0 and see if it'll go halfway across?
Yeah, let's try. Yeah.
Wow. Okay.
But some parts are a bit dubious, like 50% of Y, it seems to freak out.
I think it's just behind the square. Oh wait, no.
Oh, you're totally right, actually.
Yeah.
Nice. Cool. Any questions? All right, let's keep going. So we were able to draw HTML graphics by ourselves, and we know that HTML documents consist of tags like divs, paragraphs. We can use SVG, which functions in a similar way where you can nest tags inside of one another. And that's how we created some of our graphics. And we also have Canvas, which is something which is a bit more programmatic. They use JavaScript to insert different like circles and squares and stuff. And D3 is an abstraction over all of them. So D3 lets you control all three of those things, and you can specify what backend you want. So do you want to control an SVG or an HTML document? Those function a bit similar. So that you can totally create elements that way. If you want D3 to work with Canvas, you can do that too. So you write some sort of common code at the top, and then you just switch out the backend, and it can sort of add your graphics to either of those things. So what can you use D3 for? You can use it for any sort of HTML visualization. You can create lines, bar charts, maps. And the important thing to note is like there aren't any ready-made sort of charts available for you in D3. So there's not like a line chart component or a bar chart component that you could just like put in your data into. You have to specify all the granular sort of details, like how big should each bar be? Where should it start? Where should it end? What color should it be? What stroke should it have? What should the axes look like? So D3 is a pretty low-level toolkit. So if you're just trying to create like very like nice-looking charts and things like that, you have to do a lot of work. At that point, it might be better to just get a more sort of higher-level charting library that might be able to help you create those things really quickly in a nice way. But if you want like that sort of granular control, then maybe D3 is a better fit. And one of the best ways to think about D3 is that it's not really like a charting library. It's more like a way to transform data into pixels. So you might have a lot of data on one end, which is like on this side represented as JSON or CSV files, and you just want to transform that into pixel space on SVG or Canvas, and that's what D3 allows you to do. So any questions about what D3 is used for? Great. So I've already shown you what we're making, so we'll skip to the next slide. This is one thing that I'm working on, actually, with the help of Steve, which is something that uses various aspects of D3 to create an interactive map and to also create a bar chart. And so we're going to be looking into more of those with this sort of election sort of toy example as well. But there are also a lot of examples on this website, blocks.org, and I'll put this in the chat too. And there are lots of things you can do with it. People have done crazy stuff with it: maps, time series, trees, just a whole lot of stuff. So feel free to take a look for inspiration. All right, so Steve's going like, wow. So let's sort of get right into it with the time that we have left and see if we can crank out this bar chart and the map. So let's start with the bar chart. So in your same sandbox, let's sort of, let me bring my sandbox over here. We can comment out the SVG because we don't need it for now. We can comment out this canvas. Right?
How do you comment out things?
Oh, so you highlight the thing and then you just press Command or Control / and it comments out the whole thing for you. That's pretty convenient.
Can you see that? What was it? Can you see that again?
Yeah, so if you hold down Command, if you're on a Mac, and then /, so highlight the thing you want to comment out, Command / it'll comment it out. Yeah. Because the alternative is you type in out the comment for like manually, and that also totally works fine, but it's a little bit annoying.
Wait, how do you do that on Windows?
Do Control instead of Command. So Control /. Yeah, and yeah, that's great. So just surround all your code with that as well. That's basically what the comment's doing. So when you comment the stuff out in HTML, you get an error, but that's because the JavaScript is referencing something that doesn't exist. So we said we'll get the canvas element and then get its context. But because the canvas element doesn't exist, we get a big error. So we'll comment out this stuff as well. And notice how the comment is different. There are 2 / instead of the alligator sign exclamation. And that's because every language has its own conventions for commenting stuff out. So if you'd rather not deal with those, that shortcut is good to know, Command /. Great, so now that we have this, let's sort of go through all the steps. And I think this is a good sort of philosophy in general for working with D3. It's very mechanical, like no matter what visualization you're trying to do, it always has the same steps that I've seen. So the very first step is to prepare and understand your data. So in our final product, what we're trying to do is somehow we know, maybe from the polling station, what the tallies are for each candidate. So we know that Peter Salovey might have 100 votes, Handsome Dan 200, and so on. So we need to have that data on hand in a nice, like clean way. And if you have the slides, you can just copy this over. But you'll notice some problems immediately. The problem is that the quotes are sort of rich quotes. We want them to just be normal quotes. So just delete and add in your double quote and it'll just work. And you also want to add in a comma here. I should have added that in the slides, but. And you also want to add in a comma after /up. And then when you press save, it should format itself and it should be fine. It won't throw errors. Actually, let me just put this in the chat so you don't have to do this yourself. There we go. So we have, so now it's time to explain what all these braces and curly brackets and square brackets are doing. Square brackets means that there's an array of items. So you can also have an array of numbers like this. So square brackets means arrays, like a list of things. Curly braces in JavaScript means objects, where related key value pairs or properties get grouped together. So we have one object for Peter Salovey, which has a name, which is Peter Salovey, and the number of votes that he got. We also have another object after a comma, because this is a list of objects. So we have another object for Handsome Dan, and we have a third object for Sasha Pup. So that's what the square brackets are doing. It creates a list of things, and that's what the curly brackets are doing, or curly braces are doing. With it specifies an object. And inside of that object, you're not limited to just name and votes. You could put in any sort of key value pair. So age, you could say maybe it's like 10, and age, maybe it's like 5 or something like that. So you're totally fine there. And not all the objects don't have to respect the same key value pair. So it won't yell at you if SashaPub doesn't have an age, but sort of good to have your data standardized for your own benefit. Because later, if you try to access SashaPub's age, then you'll be in trouble because you never specified that key value pair. What questions do you have about this data?
Can you have missing values?
So it depends on what you mean by missing values. So say if for one of the candidates, you create a new, let's say for SashaPub, you don't have a name, you can leave an empty string. That's totally fine. So if you don't have your data, like for the name, you could just leave it empty and that's fine. But, or one thing you could do is just don't have the key value pair at all. So just have name, like don't have name at all. And so there's nothing preventing you from doing this. But later in your code, if you go like, oh, here's the list, my list of candidates, give me the first one. So JavaScript is 0 index. So this is item 0, this is item 1, and this is item 2. So give me the first or the first candidate at the 0th index, which is Peter Salovey, and access the votes. And let's maybe just console log that, which is where we're printing stuff. That's totally fine. We get 100 there. So let me just refresh that. We get 100. But now if we try to do the same thing for maybe the 0, 1, and 2, so the second index, which is SashaPub, we do get the votes there as well. But now see what happens when we try to access name, then we're in trouble, then it's undefined. Now that's undefined isn't actually an error, but if you have undefineds everywhere, like floating around in your code, if you try to access stuff which is inside of an undefined, then you're in trouble. So say that we had something like this, which was family. So objects can totally be nested. And a family might have like, I don't know, maybe like a mom, and she might have her own name. So let's just say name for now. So SashaPub has this nested object for, let me bring back her name just so everyone knows what I'm talking about. But so in this case, we're totally fine if we just say family.mom. That's fine. So we get name here. But if we try to do the same for Peter Salovey, for instance, then we're in trouble. Because while family was undefined because family doesn't exist. So that's undefined. So it doesn't really make sense to access something inside of an undefined, and that's when JavaScript's going to try and complain. It's going to complain. So family dot like mom, then it's like, then that's where you get your like big error.
Hey, Saram.
Yeah.
This is unrelated to the JavaScript logic, but would it be all right if I shared my screen because somebody had an issue?
Yeah.
And I'm not able to solve it, and I'm hoping no one else has the issue. But if they do, we can quickly take care of it.
Let's do it. Let me stop sharing and then go for it.
Okay. Sweet. All right. So this is what I have on the code. And
Yeah.
the issue is that the rectangle is smaller on the right side.
Yeah, it's because width 100. So
sorry, the height is incorrect.
Oh, let's see.
So I double checked width 200 here, height 200, and then width and height 200 here.
Can you sort of go to the index.js? Nothing wrong there. Let's go back. Try saving.
It's the weirdest thing, huh?
Yeah, it totally is. Interesting. See if well, this is all
if I move the SVG down here.
That's quite strange, actually. Let me
Wait, I
text
put
you.
it in the canvas. That was my bad.
Huh.
What did you put in the chat?
I put in my code for the canvas.
Okay, let me try it and then we'll see if there's anything that's completely different. This is your canvas?
Mm-hmm.
What's different?
Can you go back to what you had?
So
Command
border
Z?
one. Yeah, this is what I had before. Here,
Can you
let me
paste in
paste.
mine underneath?
Literally, they're exactly the same.
That's super duper bizarre, but oh well. At least now both of them are working.
Oh,
So
you know what it
that's
is? I think maybe no, actually, I don't know.
good. No worries.
All right, sorry to the
Uh,
person who asked me for help, but here, I'll stop sharing.
Cool. So now we have our data. We've explored it a little bit, and we have it standardized. So here. We just have sort of name votes, and all of that. So what's the next step we need to do? Now we need to create scales. Now this is the next big concept. You're working with numbers and you don't know like what the extent, like you want to map those numbers to pixels on the screen. So our SVG or our canvas has a fixed width and a height that we specified. So we said it's always going to be 200 pixels wide and 200 pixels tall. But your data, like votes, may not necessarily conform to those. So say like Handsome Dan's got like 1 million votes or 10,000 votes, but you only have 200 pixels on your screen to show those votes. So what do? So what you need to do is create a scale to basically scale your vote values into pixel values. So you know that the extent that the votes that your votes might go from anywhere from 0 to like 1 million or 10,000. You know that stuff in advance. And your pixels, you've set that to go anywhere from 0 to 200 pixels. So what you need is some sort of code to transform your number of votes to the number of pixels. And that's what we're going to do now. Can everyone see my screen okay with the slides? Great. So there are two types of scales actually, and they help you work with categorical data and also, which is useful for bar charts, but then also sort of continuous data, which we'll see is more useful for line charts or maps. So if there's this function in D3 called scale band, and it creates this scale, and you can supply a domain to it. So what are all the possible values that could go into this function? So in our case, it will be Peter Salve, Handsome Dan, and Sasha Pup. So A, B, and C, categorical variables. And then we supply a range. So these are the pixel values, like 200 pixels, 300 pixels. And what this function is going to do for us is output numbers. It'll spit out numbers for each sort of thing that we put in. So in this case, we have a domain of A, B, and C. When we supply A to this function, it's going to spit out 0 for us. So that's like 1 pixel value that can be useful. And then if we put in B, then it'll give us 100. If we put in C, it'll give us 200. So what it's doing is it's mapping our sort of categorical data to numbers. And it's a bit easier to see with the scale linear. So say you have numbers that go from 0 to 64, like 0, 1, 2, 3, 4, 5, 6, all the way up to 64. And then we say that the range of it is going to be from 0 to 300. So what it's doing is, if you supply 64 to this function, it's going to give us 300. So it's mapping on to that pixel value. If you supply 0 to this function, it's going to give us 0. It's mapping onto that pixel value. Can anyone guess what's going to happen if you supply 32 to the scale linear function?
150.
150, yeah. So it's just transforming stuff for us. Okay, so what we're doing is we have lots of numbers and we're working within the constraints of our pixels or what we see on the page, and that's why we need scales. Any questions on scales? So let me ask you a question. Given that we want to make a bar chart like this, what kind of scale do we need for the x-axis and what kind of scale do we need for the y-axis? So we have two options here, scale band and scale linear.
Shout it out.
Band for X, linear for Y. Perfect. Yeah. Awesome. So let's do that now. So I'm going to go back to my code. I'm going to start writing my scale here. So you can call your scale is basically a function stored in a variable. So you can call that function whatever you want. I'm just going to call it X scale, but you could call it my X scale. You could call it whatever you wanted. So your X scale is going to be a scale band. All right, so here we immediately hit a problem. Where is D3 coming from? Like we never installed that. So let's quickly install D3. Do you see where it says dependencies here? Just search for this dependency D3 and just click it.
On the
And you've
left-hand
installed.
side of the screen.
Yep, right here. Once you do that, go to the top of your page and just say import star as D3 from D3. And I'll put that into the text, into the chat, so everyone can import. Thumbs up when you're able to add D3 as a dependency and also do the import. All right. For good measure, let me copy everything I have so far in my JS and put that in the chat as well. So let's continue making our scale. So we want to scale band type, and we want to specify a domain and a range. So our domain is whatever is possible on the x-axis. So what's possible is Peter Salovey, Handsome Dan, and Sasha Pup. And the range, so notice that I'm chaining a lot of like methods or functions one after the other. And that's just a peculiarity of D3. So D3 starts with a scale band function, and you can call another method on top of that called domain to further configure it. So you see a lot of chains of things in D3. If that flew over your head, don't worry. It's just sort of visually, it sort of makes sense. So you don't need to know the semantics of it. That's fine. Now we're going to configure the range. And we're going to say that the range goes from 0 to 200 because that's the extent of our pixel space. Okay. Let's bring back one of the SVGs that we had. And let's just remove the circle and rectangle. We're going to use that for our bar chart. Okay. So we have our X scale now. We also need a Y scale. So for the Y scale, we're going to do scale linear. Domain 0, 300 is the extent of like values that we can have. So, and this you can play around with. So the y-axis is showing number of votes. So if you look at our data, we've got 100, 220 votes. So maybe like the maximum number of votes one can receive should be capped at around 250 or something like that. But that's something you can play around with. So it's like, how many values do you expect for the number of votes? And we say, yeah, the maximum value of votes that we ever hope to see is probably not going to be any more than 300 or so. So that's our domain. And then we just configure the range, which maps from 0 to 200. Yeah. So there's actually something interesting that I want to show you now. If we use our y-scale function here and start supplying it things, so maybe like 50. So what would our y-scale give us if we supplied in 50 votes? It would give us 40 pixels. That would be the thing it outputs. What we actually want is, since we know that our y-axis, our origin is at the top left, we actually want to do the opposite. So we want to flip our y-scale in terms of pixels. So what I mean to say is, if someone had 300 votes, it'll get a pixel value of 240, sorry, not 300, but 250. Because that's the extent of the stuff that we supplied here. So yeah, so if you give 250 votes into our y-scale, it'll spit out 200 pixels. But can anyone tell me where 200 pixels on the y-axis is on this SVG? So it's right at the bottom. So we don't want that. So if someone has a large number of votes, we shouldn't put them at the bottom of the graph. We want our rectangle to start a bit higher up. So what we want is for the Y scale to be flipped. So if we say that our range is from 200 to 0, then it makes a bit more sense, because if you have 250 votes, you start from the top of the graph and you start drawing the rectangle down. If you have 100 votes, you start somewhere in the middle at 120 pixels and you start drawing the bar down. And if this sort of doesn't make sense because there isn't a visual sort of indicator, don't worry, we're going to do that in just a moment. And I'll come back to this, of why we flip the scale. But for now, I can copy it into the chat. You can set up your Y scale as this, and it should be fine. But it's always good to sort of try some test numbers and get the output and see what you get. All right. So now we have our scales. What's the next step? We want to bind our data to elements, basically create our graph. And D3's sort of methodology of working with data is a bit sort of arcane, but I'm going to try and demystify it as much as possible. There's a bunch of things that you chain together, but it all works. So let's do the first. So let's start binding our data to elements. So our data, just to refresh everyone, is this stuff. And now we want to put in some elements into our graph. So how do we do that? Well, first we need to select the SVG, same way like document.getElement by ID, excuse me. But this D3 actually has some helper function to select stuff in a much easier way. So we can just say D3.select SVG. Now, with your selection, you can start doing stuff to it. So we're going to select all sort of elements with a bar class. And we haven't made anything with that class yet, but just bear with me. We're going to attach data to them, which in this case is candidates. And for each of those candidates, we're going to append something. And what are we going to append? A rectangle. Okay, so just click save there. And this is just the way by which we connect bars in our SVG to data. So each of the rows in our candidates is now connected to a rectangle. But we haven't drawn anything yet, so we're just going to do that too. So for each rectangle, give it a fill, right? So maybe you can give it a red fill. But right now, the rectangle doesn't really have a width or a height. Or a position really. So now we need to give it an X position. So the X position is, we can just give our X scale to it. So the X scale will help us decide what the X position should be. And we can just leave that. Let me just type all of this out and then I'll explain further. The Y position is given by Y scale. And then we just give a height as well. Maybe 20 or something. Let's see.
Does it need a width?
Yes, it does. Good catch. So let's do a width and let's do 10. Perfect. So in this case, you see that, let's refresh. We've got some stuff, okay, but it's not desirable just yet. But we can confirm that all three rectangles were drawn. How we can do that is just by right-clicking and clicking inspect. And just click this thing right here, select an element in the page to inspect it, and you can click on the rectangle. And so we do have three rectangles. We've got one that's of width 10 and height 20, one of width 10, height 20, and one of width 10 and height 20. What we don't have is the X positions and the Y positions just yet. And why is that? Because we just supplied our X scale function, but we don't tell it like what part of the candidates to sort of work on. Like which property of each candidate is the thing that's going to be input into the X scale function. So what we can do is supply a function instead as the value of this property, where D is just a placeholder for that sort of candidate. You can call it whatever you want. So it doesn't have to be D, C, anything. So I'm just going to call it D. And then you can return X scale, sort of transforming that value of the value we're interested in for each candidate. So D dot name. All right. So that's one thing. And then the next thing we want to do is do the same for the Y axis, where we return Y scale D dot votes. All right, let's close out of this and take a look. So now we're getting somewhere. What's happened here, and let me actually copy this too into the chat so everyone can follow along. And let's go through this line by line. All right, so in your SVG, we assume that they're going to be rectangle elements with dot bar class. Okay. We attach some data to each. What we're trying to say behind the scenes, D3 is hooking up each sort of rectangle to one piece of data, like one candidate. So there's one rectangle for Peter Salloway, one for Handsome Dan, and one for Sasha Pup. So this is what's doing that actually. It's binding the data to each element. And then we create elements if they don't exist already. So that's by doing this enter append thing. So what is the element that you're creating? A rectangle. Specify the property of how, specify how the rectangle should be drawn for each candidate. So, and these are all attributes that we saw earlier when we sort of messed around with the SVG just by ourselves. So there's fill, there's X position, there's Y position, and now we're just doing it within JavaScript. So we're giving it a red fill. We're specifying the X position, and in this case, the X position comes from our scale. So it looked at the first name, which is Peter Salloway, and we put it into the X scale function, and it spit out 0, and that's why this one's X position is at 0. We go to the next one, Handsome Dan. We input that into our function X scale, and it spits out 100. That's why this sort of rectangle is at position 100. And we go to our last one, Sasha Pup, and we put that into our X scale. It spits out 200, which is why this last rectangle is at 200. That's why its starting position is there. Okay. Our Y position is similar, where the Y position is given by our Y scale. So we went to our first one, Peter Salloway, with 100 votes. We put it into our Y scale function. What our Y scale function did was just output a number between 200 and 0. Because our Y scale was flipped, it put the position all the way down here. So what that means is higher votes means you get a smaller Y position to make it closer to the top. Fewer votes means a larger Y position, so you're closer to the bottom, which is why Sasha Pup, who only had 20 votes, got the largest Y scale output value and ended up right here at the bottom. Okay, so there are a few things that we can do to improve the look of this. The one thing we need to do is fix the height. It doesn't make sense for each rectangle to just have a height of 20, otherwise they're just hanging out there in midair. So how can we fix this? Well, we want to know what's the sort of difference between this point and the end of the graph. Okay, so does anyone want to take a guess? If I have this Y position at maybe 20, and we know that the height of this graph, or the height of this whole SVG is 200, how do we come up with the height for the rectangle? So let me say that again in a clearer way. We have our starting height position, or starting Y position for a rectangle, say 20. We have our SVG height, which is 200. What should be the height of this rectangle so it goes all the way to the bottom?
Do you like the scale subtracted by the height of the votes?
Yeah, so let me see. So what's this sort of measurement from top to bottom?
Y scale, right?
Yeah, but we also hard coded this as being
Oh.
200. Yeah, and so given that this sort of distance is 20 and this distance is 200, all we really need to do is 200 minus 20 to get 180 for the height of the bar. And it's a bit easier if I just set the height for now as 1. So you have these like sort of lines hanging in space, and our height can sort of go sort of 20, 40, 50, 60. It keeps going downwards. And we want it to extend all the way to the bottom. Like one hack we could do is just give it a really large one, and that's totally fine. But if you want to be mathematically precise, all we need to do for the height is just say, give me the Y scale for the votes, but also just do 200 minus that. Yeah. Did that fly over people's heads? Should I go over it one more time? So the big sort of question was, how can we make our bars look nicer? And if we just return sort of 2, for instance, or 1, we need to come up with a height for each bar. And we know that we have a coordinate system starting at 0, 0. So for this guy, and we can actually print out the Y scale or the Y position for everyone. We have 120, which is the position, the Y position for the first one. We have 40 for Y position for the second one, and we have 184 Y position for the third one. So the Y sort of the Y position values, sort of the more votes you have, the smaller your Y position is. The less votes you have, like Sasha Pup, the greater your Y position is, because we flip the scale. So what we're doing here is calculating the height, which is basically this difference in value. So we have a Y position up till here, say 120, and the height of the bar should just be 200 minus 120, which is 80 for the first one. So we just say 200 minus Y scale D dot votes, and it sort of completes the bar. Let me copy all the code. Oh, it won't let me copy too much. So I'm just going to copy this part. If that's still unclear, just feel free to give it a height of like a really large number, and it'll just flow all the way to the bottom. That should be good too. Okay, so Melanie, is that right? You said, can you show an arrow function implementation? I think she may have been referring to this.
Yes, that's correct. That's what I wanted to.
Yeah.
Wanted to see what that looks like.
My bad. But you meant draw a literal arrow.
Yeah, but that's how you do it there. And then going back to getting your data, if you import a CSV file, how do you arrange it to be in the format we typed your data? D3 actually has a CSV function, which gives you a JSON representation of your CSV. So you can just do D3 .csv and the path to your file. So my file.csv. So you should try that, and it'll give you your data. Does D mean something specific, or is it just a generic return value name? It's a generic value name. So you could call it my param, or so there's nothing special about using D. D just refers to each of these rows. So this row, and this row. Okay. So one sort of final adjustment we can make is we also know what each bandwidth is. So we have 3 candidates, 200 pixels split between them. So we can set a bandwidth of like 66 or something so that each bar is wider. So instead of just doing a width of 10, we can just say 66, and immediately it's better. If you don't want to do it that way, you can also just do X scale bandwidth because it stores it for you, and that's fine too. And if you want to make it slightly less than the bandwidth, you can just do -10. So it calculated the 66.6 number for you and just do -10 to give some bit of breathing room between each bar. Nice. So now how do we get the colors? That's also very similar. Imagine our data had colors for each candidate. So maybe blue for Peter, red for Handsome Dan, green for Sasha Pup. We could also adjust the fill so it no longer has to do with just a fixed red, but we could just say supply a function where we access each row and then just return d.color. Let me copy that for you. Let me copy it in two parts actually. First, the data. No problem, see you. And next this. Cool. We're up with our hour, but I can keep going until 8:30 and we'll see how far we can go with the map, if that works. Because for the bar chart, all we need to do is add our scales. We could skip that and go straight to the map if that's more interesting for people.
Make the map.
Map? Okay, sounds good. Okay, so now let's go to the map. I'm actually going to do it in another SVG just for simplicity's sake. And same setup. This time I'll make the width a bit wider, maybe 500, and the height can be 200. Okay. I can just comment this out, the first one. So actually, I'll leave that as is. All right. See you, Steve. Thanks for coming. Bye-bye. All right, so let's do the map. So for the map, we actually need two data files. So it's very similar. What we're going to be building is a choropleth map, colors in different patterns or shades. You shade the map territories based on some statistical variable. So number of votes, number of coronavirus cases, so on and so forth. Any sort of variable that you have, you can transform that into a color. And D3 will help us do that as well. There are actually color scales that you can use, but what we're going to be doing is just coloring red or blue based on which party is winning. So again, same setup. We need to prepare our data first. And if you go to the email I sent you before this workshop, I linked to an attachment which has a zip file. In that zip file are two files. It says US states geo and US states votes. So here I downloaded this from the email. Open it up. There are two files here, US states data, US states geo. You can just go here, you can drag it on. And the next one, US states votes. Okay, now let's see what the data is. Votes is, I just made this up at random. For each state, it just tells you the breakdown of blue versus red. And these are all random numbers. They don't reflect any reality. Interestingly, the map is kind of inverted compared to the actual election results. The middle of the US is all blue and the edges are red, but that was completely random. It wasn't intentional. And then if you go to US states geo, you'll see there's a lot of data. And what this is basically latitude and longitude coordinates describing the boundary between each state. Okay.
Sorry, I think I missed this. Where are the files at?
So you know the email I sent, which was like D3 workshop tonight, right there is a small link which says US states data.
How do you import them again?
Just click it. When you see the files, drag it onto the code sandbox.
Gotcha.
Yeah. Cool. So now that we have the data, we know that one file consists of geography. The other file consists of vote counts and colors. This should be votes. Okay. We've explored it. The next thing we want to do is create our what are basically scales. With geography, it's a bit different. We call them projection functions. We need to choose a projection. I'll go into what that means, but basically there's a lot of ways to represent the Earth. The Earth is a globe. What happens when we try to project a map wrapped around a globe onto a two-dimensional surface? There are a lot of choices you can make. How do you unwrap that globe and stick it onto a flat plane? So there are many different projections out there, Mercator, Albers. So I'm just going to choose Albers for now. We're going to configure that projection a bit. So we point our camera right at like what we want to see in that flat plane, which is the United States. And then we're going to create a path generator that just takes in some latitude, longitude, and spits out pixels. Very similar to X scale and Y scale, but we just name stuff a little differently. So in the interest of time, I'm going to copy these magic incantations into the chat and people can just see you. Bye-bye. So we are going to make a function like this called render map, which is going to render our map for us. We are going to select our map from here. So let me do one thing actually. Let me go back to my index and give my map an ID so that we can select it here as an SVG selection. Cool. And then we're going to load up our data sources. So our geography and also our votes. And let me put this for you in the chat so you can have it immediately. So what we've done so far is created a function called render map, which just selects the SVG and imports all the data. And we're going to call this function render map here underneath, so it gets called. Let me put that in the chat too, the whole thing, so you have it. All right. See you, Jenny. And then there were two. So then we just need our geoprojection and our geopath generator here. And let me actually copy the whole thing over so you can just see the final result. And then in the last few minutes, I'll just comment on what each piece is doing. Okay, so first we got our map. We got a reference to the map element, which is here. Then we, whoops, I'm trying to copy it over. Then we set up our projection. So in this case, Albers USA, and we sort of translated our projection to the middle of the SVG, which is 500 by 200. So we translated its middle to 250 by 100. So it's right here in the center. And we scaled our projection. So you can play around with the scale actually and see what happens. So this is really big. It's like zoomed in. You can also make it really small. So 300 seems to be appropriate. And then you set up your scale or geopath generator, which just accepts your projection that you set up. Now, the rest of the process is very similar to the bar chart. So within your map SVG, we selected all path elements, whether they exist or not, and we bind some data to them, which is geojson.features. Okay, let me sort of show you what geojson looks like. You've already seen it in the file, but here it is in JavaScript in the console, right here. So your GeoJSON file consists of a feature collection and just a bunch of features. Each feature has like the state that's describing, name, main, and geometry, which consists of a whole bunch of coordinates. So this is a standardized format called GeoJSON. And then we just supply it to our geopath generator. And it creates paths for each of those points. So these are latitude and longitude coordinates. There are a bunch of them. And it takes all of those and creates path elements for each of them. And then we can set all the other properties like stroke, stroke width, and fill. So the fill is the interesting stuff because we didn't actually have, you can actually do this right without fill and it's totally fine. But we just get black because it just has a default fill of black. Or you could just say, give me a fill, but just set it to none so that we only see the outlines. Now, the question is, how do we merge our coordinate data with our votes data, which is all here? And we can do that pretty easily by sort of just setting up our fill function to do a little bit of like work for us. So what we're saying is for each of those, for each sort of state, which is D in this case. So D refers to sort of each element in the array. Get the name of that state, and we have that. For each feature, you have the name of that state, like main, which is d.properties.name. Look that up in the US states votes data. So if you had main, for instance, it'll go here and say, oh, the blue votes are 548 and the red votes are 654. And based on that, just do a simple calculation. If the blue votes are greater than the red votes, you return blue as the fill color, otherwise you return red. And that's how this coloring is happening. Yep. So yeah, that's, sorry we went over, but that's basically all you need to know really to how to get started. There's a whole bunch of stuff you can do, but if you follow this process about getting your data and then sort of working with your scales and then rendering stuff and attaching your data to your HTML document, then you're in good shape to build any kind of visualization. Awesome. Yeah, any questions? Any parting questions?
It's just Nash and Justin left. Yeah, I'll stop the recording and then we can.
Yeah.